Hey guys, this is KD and welcome to gettutorials.com. Today I'll be showing you around some of the basic electronic components which are generally found in any electronic circuit on any PCB, which are the building blocks of any electronic circuit. So let's start with resistors. Now, anything short of this tiny bug you find in electronic circuit are called as resistors. Also this and this. So what basically a resistor does, it basically obstructs the flow of electrons. It obstructs the flow of electric current, and the value of this resistance is counted in ohms. So ohms, it is named after the famous scientist George Ohm, who propounded the Ohm's law, which goes as V is equal to I times R. Voltage is equal to current times resistance. So as I said earlier, these things resist the flow of current, and as you can see, there are certain colored stripes on these resistors. So let me zoom in a bit. Yeah, different resistors have different colored stripes on them. Now these colored stripes are markings of what is the value of ohms which is assigned to this particular resistor, and someone has devised a chart from which you can determine the value of what particular ohm this resistor is. So it is given by B.B. Roy of Great Britain, had a very good wife. Now I'm going to show you how to find out what ohm this resistor is depending on the color bands present on this resistor. Basically there are four color bands. So according to B.B. Roy, the first band present is brown. So brown stands for 1, and the second one is black. Black stands for 0, and the third band is orange. Orange stands for the number of zeros, and the number of zeros present for orange is 4. So this resistance is typically of 10k. 10k as in 10 kilo ohms, because 1k is equal to 1000, so 10k goes for 10,000 ohms. Similarly, coming to this, now all the bands as you can see from left to right are red. So R is assigned a value 2, so again go for 2, and the second band is again 2, and the third band is also 2. So R will be given, the third band, that is the multiplier band, will be given a value of 2 zeros. So 2200 ohms, which can be also written as 2.2 kilo ohms. Now let's come to this third one. Whoa, it has a blue color on it, and a gray and a red. Going to blue, blue shall be 6, gray shall be 8, and the red one shall be 2. So that is 6800 ohms, which accounts to 6.8 kilo ohm. Going to the fourth band on your resistor, it is the golden band. Now the fourth band stands for tolerance, and the tolerance for the golden band is plus or minus 5%. Say for example, this resistor is of 6.k kilo ohms, 6.8 kilo ohms, then it will have a tolerance capacity of plus minus 5% of 6.8 kilo ohms. If the band is silver, it would have a tolerance capacity of plus minus 10%. If it is white, then there is no tolerance, and if there is no color, then the tolerance is plus or minus 20%. And mind me, the tolerance is always in percentage. This is basically all about resistors, and these resistor comes in different amount of wattage, that is half watt, 1/4 watt, and watts is basically the power which which the resistor can hold. And this power, you can find out this power as voltage times current. So it is a voltage flowing through the resistor and the current being drawn. So now these are the general resistors, and if you are looking for surface mounted resistors, they may look something like this over here, which are right next to my thumb. Yeah, this thing right here is a surface mounted resistor which is directly mounted onto the surface of a PCB. Okay, good enough. Yeah, and the value is just directly written on the top of the resistor. So that's all about resistors. Now we shall be moving on to capacitors. So this thing right here is a capacitor. Now what a capacitor or a condenser exactly does, it basically stores a amount of charge, and the value of this capacitance is counted or measured in farads. So this capacitor right here is of 470 mu f. So mu stands for micro. So 470 microfarads, and its voltage rating is 35 volts. So do not use this capacitor over 35 volts, otherwise I can't help you. And as you can see, one of the leg is smaller and the other one is longer. So it has a polarity. The smaller leg over here has a negative sign. So this is the negative terminal or the cathode you can say, and the longer one shall be connected to the positive terminal in your circuit. So there are different types of capacitors available to us. This is a electrolytic capacitor. I have a circuit of, let's say, a metal detector. So there are various components as you can see. Let me focus. And yeah, these tiny orange things are ceramic capacitors. This orange little thing, flat thing, is also a capacitor. And if you want to go into theory, capacitors have a dielectric medium which generally acts as a insulator. That is a basic thing which helps the capacitor in storing the charge. And if you are coming to surface mounted, these two cans right here are surface mounted capacitors. Now what I'm showing you here are diodes. Now these tiny little black things are diodes, and as you can see, every diode on them on the rightmost side have a gray sort of ring. So that is the cathode part of the diode. And yeah, diodes have polarities, unlike resistors don't have polarities. And diodes generally, act as a switch. So let me just show you how do you represent a diode on a paper. Triangle and a hyphen. So this is basically a symbol of a diode. And say for example this and this cathode, this hyphen, this dash part is the cathode, that is the negative part of your diode. This diode basically acts as a switch. Say for example this diode is forward based, and if you are applying a positive supply over here, then current is allowed to flow. If you are applying a negative supply to this terminal, current is not allowed to flow. So basically a simple sort of switch you can use in this electronic circuits. Now, if you guys want me to extend the topic of these diodes, I would like to say that LEDs are short for light emitting diodes. As you can see, one of the leg is shorter and the other one is longer. It is a diode which emits light when a certain amount of voltage, a certain amount of power is supplied to it. Now, these are different current consuming LEDs. This LED consumes a lot of current while the other one consumes a very little amount of current. So an LED is a diode. A circuit over here, and I want you guys to concentrate on these four black things. These four things are called as transistors, and these are three leg things. Transistors generally act as a switch. They can also act as a amplifier. So they are generally used for amplification purposes as well as switching purposes in any electronic circuit. This thing right here is a transformer, basically a step down transformer. So if I apply input voltage of 230 volts AC, I can either get a output of 12 volts or 24 volts when I connect these two wires. So basically a center tapped transformer 12 0 12. So when I connect these 12 and 0, I get an voltage of 12 volts, and when I connect these two wires of 12, I get an added voltage of 24 volts. So a reduction from this 230 volts to 12 volts or 24 volts. So this is what basically what a step down transformer does. This thing right here is a rectifier. Now what a rectifier does, it basically transforms your, basically it converts your AC voltage to DC voltage. So if you give AC current over here, line and neutral, it will give you positive and negative output to these two extreme wires. So with the help of your transformer and your rectifier, you can make a simple battery charger by using perfect values of this rectifier and transformer. And in any circuit you come across this black things, these black chips. These things are called as ICs, abbreviated form of integrated circuit. Now there are lots of components embedded into this one single IC. This thing right here is a motor driver IC. This thing right here is a voltage regulator IC 7805. If you give it a input of 12 volts, it will give you an output of 5 volts. This is a microcontroller IC with 32 kb capacity. So these black things are ICs.